Welcome to today's session on embedded systems. Today we are going to discuss about the topic called communication software. Mostly embedded systems use a communication interface to interact with the external world. To communicate with the device, an embedded system uses a hardware interface. Additionally, it also needs an application software or a communication software to be integrated with the firmware. So, an embedded system, if it has to be network enabled, then it has to obey any of the protocols. So, in case if it has to be accessed anywhere inside the world, so it has to be network enabled and has to obey a TCP/IP protocol. So normally a protocol is nothing but a set of rules that has been defined in several layers. When we come in detail about the TCP/IP protocol, it is called as a 4-layer architecture. So the first layer is called the application layer. The second one is called the transport layer. The third one is called the IP or internet layer. And the fourth one is called the network interface layer. So the advantage of these layers are independent of their individual layers, and it has got an advantage of traceability, reusability, and etc. So if a code has to be developed in a particular layer, it will not disturb the other layers. That is why we use such ISO standard protocols. So now let us see in detail about the TCP/IP protocol stack. So the communication software provides the communication interface for the embedded systems with the external world. Example, Ethernet interfaces TCP/IP stack. So when we come to the TCP/IP protocol suite, in packet switching, data has to be transmitted from the source to destination. For example, let us assume that a person has a set of puzzles that has to be transferred to his friend at a different place. Now, he packs all the puzzles in a parcel and takes to the post office. Now, we call that layer as an application layer. So when the postmaster discusses that the entire parcel cannot be sent on a stretch, so in that case the entire parcel is splitted into small packets. So this function is being done by the transport layer. Since the packet has been splitted into small packets, an address is indicated on each and every of the packets. So these packets assigning address to the small individual packets, then that is done by the IP layer. Once the address has been defined, so the address on the packet defines the destination address. Now the network interface layer places the individual packets on a truck and sends it to the destination. So this is done by the network interface layer. When the user receives the puzzles at the destination, he reassembles to it to get the entire picture. So as we discuss, each layer has some individual functions. So when we discuss about the TCP/IP protocol suite, in packet switching, data has to be transmitted and it has to be divided into small packets, and once it reaches the destination, it has to be reassembled again. During transmission, some packets can be lost or some packets can be delayed and some packets may not be received in sequence too. So to avoid such problems, we go for the TCP/IP protocol suite. The TCP/IP protocol suite, as we discussed, it can be classified as a 5-layer or 4-layer. So the first one is called the application layer. The second one is called the transport layer. The third one is called the network or IP layer. And the fourth one is called the data link layer. And the fifth one is called physical layer. Together, the data link and the physical layer sometimes is called as network interface layer. As we discussed that each layers which will have individual functionalities, let us discuss in detail about the functionalities of each and every layer. The physical layer. The physical layer defines the characteristics of the transmission, such as the data rate and the signal encoding schemes. Next comes the data link layer. So the function of the data link layer is to establish a link, transfer the data from the upper layer, disconnecting the link. And sometimes the data link layer has two sub layers. One is called the link layer and the next one is called the MAC layer. Next one is the IP layer or the Internet Protocol layer. The function of this layer is mainly addressing and routing. Each system is connected and given a unique IP address. Based on the IP address, the router forwards a packet from source to destination. If this route is unreliable, then the packets may be lost or may not arrive in sequence. Hence, the next layer comes is the transport layer. So it provides end-to-end transfer service between the systems connected to the internet. So through acknowledgements and retransmissions, it ensures whether the packet reaches the destination. So the transport layer follows specific protocols like the transport TCP and UDP, Transmission Control Protocol, that provides a reliable end-to-end transfer, ensures that all the packets are received without errors. It puts all the packets into sequence and gives the packets to the upper layer, which is nothing but the application layer. The other protocol is called User Datagram Protocol. It provides a connectionless services. It sends the packets one after another without bothering whether the packets has been received correctly. That is, it does not wait for any acknowledgements. So next is the application layer, which is the creamy layer. It differs from an application to application. Two processors on two systems communicate with the application layer interface. So the application layer has specific protocols like FTP, HTTP, SMTP, etc. Once the software is being coded onto the system, if it has to be dumped on a hardware, then the application software or the coding whatever we developed has to be executable. So for example, the application software has to create several steps. The first one is a source file has to be created, then it has to be made executable. So then we have to give a command for execution. Then the process is being loaded into the RAM by the loader, and then the loader transfers the control to the process and the process begins to execute. So normally we write a program in high-level language such as C, C++, etc. So sometimes we also write the program in assembly language. So if we want to make it executable, a machine has to understand it. So the high-level language or the assembly language where we have written the program has to be converted into machine language. For that, we need some compilers. So let us discuss with this block with the block diagram. So let us discuss the process of generating an executable image. So we write the program the source files are written in C, C++ or assembly language. Now we need a compiler if the source has been written in high-level language. If the source code has been written in assembly language, then we need an assembler. So once this assembler and compiler converts this high-level language into machine language, then we call this as object files. And sometimes we need a linker or a locator which links the object files with the library files and make it executable. So once an executable image has been obtained, it can be dumped or downloaded to the target system so that the application can be run on the system. As we discussed now, the object or the source, as we discussed, the source files written in C, C++ or assembly language are converted into object files using a compiler or an assembler. The object files can be in many formats. Commonly, it will be in common object file format COFF, and executable and linking format is called ELF. Object files will contain the name, size, processor specific instruction and data, the symbol table, debugging information. The linker we discussed in the block diagram combines various object files including the library files used in the program and create executable image. This is done by the linker. It combines the object files. It also tells about the exact location in the memory where the binary code and the data is placed in the target embedded system. It also indicates the address on the memory map where the executable image is stored. The output of the linker is the executable image that has to be transferred onto the memory chip. The executable image or bootable image can be run on the target system. So next, for example, if we develop the software in one system and dump it to another system or target system, we call that as a cross-platform development. So an application developed on a desktop system which is called as a native development, and execution is also done on the same place, then we call that as a native development platform. In some systems, development is done on the desktop and the software is transferred to an embedded system. This is called as a cross-platform development. The process of cross-platform development is that the development of software is done on the host system, then compilation is linking is performed, then it is being downloaded to the target system, and then debugging is performed on the target system. As everything is okay without errors, then transfer the software to the ROM or flash, then run the software on the target system. Hence, this is done by the cross compiler, cross assembler, cross linker, cross debugger, and so on. The executable image can be transferred to the hardware in some ways. So first one is called programming the EEPROM or flash, downloading the image through the communication interface, or downloading through the JTAG port. The embedded loader or the embedded monitor are used by the hardware to initialize or the embedded system into boot up mode. Hence, the embedded loader identifies where the program resides in the ROM, executes when the power is switched on, initialize the hardware and executable bootable image, and the executable image is transferred to the RAM and the software is transferred to EEPROM or flash. Next is the boot sequence. An embedded system can be booted in one of the following ways. Execute the ROM by using the RAM data. Execute RAM after loading the image from RAM. Execute from RAM after downloading from the host. Once the boot sequence is completed, the target software will start running. The software does the following things: initialization of the hardware, memory and bus interfaces, initialization of the OS, the kernel objects, memory management devices, and the stack tasks are also created. It also initiates the application code. So in order to make this a complete format, we need some development and testing tools. We need separate development and testing tools for hardware and separate for software. Some of the hardware development and testing tools are the digital multimeter, logic analyzer, oscilloscope, spectrum analyzer, and so on. And the software development and testing tools can be the cross-platform development tools, ROM emulator, EEPROM programmer, then instruction set simulator. So, a communication software to function completely, we need a system to be integrated with the communication interface. Thank you.